Okay, I thought I'd make a video here today about infrared remote controls. Quite often people want their robotics or computer projects to be able to control stuff in the real world around their house. Through infrared remote controls is one thing. I have remote controls for my air conditioning and temperature control, TVs and videos and stuff like that. You can get infrared remote controlled light bulbs and power switches and stuff like that as well. So I thought I'd have a bit of a go at cracking these remote controls. Right? So I'm just using a little Raspberry Pi with just a little infrared receiver, and it's connected to my Raspberry Pi so it can gain information about the infrared. And I've also connected up my scope here so you can see live on the screen what's actually happening. Now a little bit is, there's a standard protocol normally for infrared remotes. They send 2 bytes of information, an address byte and a command bit, a command byte. And the idea is you send out the address of what item you want to speak to, and then you send the command of what you want it to do. This way you can have up to 256 different infrared remote control items around your house without them conflicting against each other, and each of them can have a total amount of 256 different commands you can give them. Now how it normally works is you send, the protocol normally works is there's a long on and off, which is a start byte, so you wait to receive the start byte, then you read these short little on and offs, and it sends the address, then it sends the inverse address as sort of a checksum, then it sends the command and the inverse command again as a check. And how it works is it's always turned, the infrared light is always on for the same amount of time, but it can be off for different amounts of time. If it's off for a long period of time, then it's a 1. If it's off for a short period of time, then it's a 0. So I've wrote a little program that will go along and it'll wait till it sees that start. And once it sees that start, it'll record all the short and long spaces, and it'll put it together into 4 bytes and display it on the screen for us. So the very first remote control I did, I got out there and I was pressing it away, and you can see it come up on the oscilloscope there. There's all our little ons and offs, and when I press up, you see it comes up on the screen there. All right? And this was beautiful. When I got this and put it together, it was lovely because byte 1's 32, byte 2, which it should be the inverse to check it. So if you add the 2 together, they should hit 255, sorry, so 32 and 223 is correct. Now the next 2 is the command and the inverse of the command, 64 and 91. You add the 2 together and it was lovely. Also what should happen is, as I press all different buttons on this remote, we still should get the same address, but be getting different commands as I go through different buttons there. So when I come up there and have a look, see each one of them, had byte 1 was 32. So they all had the same address, but when you see the command byte, when I press different buttons, it gave different command bytes. So I was just, yeah, lovely, beautiful. My remotes fall lovely into this protocol. The very second remote I got out was one of these, which I had lying on my desk. And when I started running through it, I found identically the same thing. So I'll press a few different, point it at the bit there. And it came out beautiful as well. It had address 0, and of course with the checksum, 255, so 0 and 255 makes 255, beautiful. Command byte 24 with 123 on the first button, the second button was 16 with 111, the third button was 194 with 61, and when you added them all together, they all added up lovely to 255, so everything was going along smokingly wonderful. Right, then I grabbed another remote control out of the bedroom for a different TV, and when I went to use it, I found it had a slightly different protocol. What you find is that instead of sending the inverse of the address, it just sends the address twice. Then when it sends the command, it sends the inverse. So when I use all different buttons on this here, you'll find that all the different buttons all give the address 244, 244, but you can see they give different commands. So this one had a slightly different protocol. With the address, it didn't send the inverse, it just sent the address twice, that you could check it that way, and then the command it sent as the inverse. The other thing that happened with it, if I can actually get to the point where I can actually capture this here, what I've done is I've just captured that wave. How it should be is we should have a long on for 9 milliseconds and an off for 4.5, then the address, the inverse, the command, the inverse. what it actually did was, instead of having a long on, a 9.45, a 9 millisecond on and a 4.5 millisecond off, it just had 4.5 and 4.5 and then the command. And you can see here, there's the address, then there's the copy of the address, then there's the, after the copy of the address, then there's the command and the inverse of the command. So it's got two gaps, 2 bits sticking down, 4 a whole heap of short ones, a whole heap of big ones for the inverse. All right. Whereas if I capture one of my ones that follow the protocol properly, so this was the original one, and you can see it has the long gap of 9 milliseconds, then 4.5 of the on, then it has the address, then it has the inverse of the address, then it has the command, and then it has the inverse of the command. All right, so I had to modify my program when it was looking for the start bit, not just to look for a start bit that's 9 millisecond long, but actually look for a start bit that might only be half as long. And then of course, if we're going to retransmit that, when we're retransmitting it, we need to know that. So I changed my program. You'll see in my program there at the beginning there, it tells me whether it has a big start bit. So for that one, it says true. If I use one of these other remotes that don't have a big start bit, this one here, you'll see up there it gives me a false, so I know that it's got the shorter start bit and the slightly different protocol. Right, now I'm going along quite nicely, and I then grabbed this remote control for my air conditioner, and what I found with this one, and I unpause that, when I used it, it has a slightly different protocol again. What you'll find is that, that's the other one, hang on, let me get pointed at him. Come on, baby. I need some new batteries in this thing. There we go, it won't come up. Right. It has a nice big start bit, but when you find the address, they're not the inverse and they're not a copy. It actually uses 2 different bytes to give the address. But no matter which button I press on the remote, I still get the same 2 bytes for the address, but a different command bit. And the command bit does work by doing the inverse. So it gives an 8-bit command and the inverse command, but the start bit was quite different. So it was another slight little modification, but it's okay. The program I have there handles that. Then I got out this remote. This remote here was quite different. It has a very different protocol. And what you'll find is that my program won't pick him up. There he is coming across the screen. There he's much longer. I'll just put this tablet down and pause that and zoom in on that for you to see. So here's this one on the screen. It had the 4.5 millisecond and the 4.5 millisecond start bit instead of your normal bit. It had 2 different bytes to send the address, the same as what the air conditioning one did. But then when it's getting ready to send the control byte, it sends another start bit, which is a 4.5 and 3 longs. But once it's done that, then it sends the 3 longs and 1 short, then it sends the command byte, and then it sends the inverse of the command byte. So you see 3 gaps there, lines up with 3 shorts there. Then after the 3 shorts, there's 2 big gaps, 2 little shorts. And then after that, there's 3 big gaps and 3 little shorts. All right, so then it sends the command there. So it had a second start bit in the center here. And no matter which button I press, I end up with the same start bit, the same address, the same second start bit, but you end up with a different command and then always the inverse to check it at the end there. So that was a bit of a different protocol. It's quite different than the simple little program I wrote basically for the purpose of capturing NEC protocol codes. Won't capture that particular remote, but there's a few little modifications I made to be able to handle the different length start bits, and also the fact that sometimes it can send its address a little bit different. My program will cope with that. So I've now got a program that you can go along, record all your buttons on all your remotes, come down, press each button, record the 4 bytes and whether the start byte's a big byte or a small byte, write them all down, and then I'm going to make I have made a transmitter. I'll make a second video of how this one works, and then I play it back. And that way my robot can control anything these remote controls control. except for, of course, this one. I need to write a little bit of a different program for that. I will eventually put all this code up on my GitHub and make it public. That should happen within the next few days.